So, good evening and welcome to our today's class. We are going to talk about WAN concepts for this class. You realize that in the previous chapters, we have majorly been talking about protocols within the local area network. In the second module, CCA network, we did talk about a lot of switching concepts. We talked about routing concepts, and everything was always within the LAN, within the local area network. So today we are going a notch higher, and now we are going to talk about wide area networks and what are some of the protocols involved. What are some of the ways of connecting to the internet? And so some of the objectives for our class today, we are basically going to explain how WAN access technologies can be used to satisfy some business needs. We'll also describe the purpose of a wide area network, how wide area networks operate. We'll compare traditional WAN connectivity options to the modern ones. And then we'll also, compare internet-based connectivity options. So that is going to be the basics of our learning today. And then when you're done, we can talk about VPNs briefly before we can end this. So to start us off, looking at the contrast between the LANs and the WANs, basically a wide area network is a telecommunications network which covers a very large geographical area, and it goes beyond the boundary of the LANs. And now checking at the table, just displayed here, LANs provide network services within a very small geographical area, while WANs provide network services over very large geographical areas. LANs, on the other hand, are used to interconnect end devices, while WANs are used to interconnect remote users, local area networks, and remote sites as well. Excuse me. A LAN is normally owned or managed by just a single organization or a home user. But a WAN is normally owned and managed by an ISP, all right? It could be a telephone service provider, a cable internet service provider, or even satellite internet providers. LANs has a very small fee to use, okay? There's no or very little fee that is posted on the LAN, but on wide area networks, you have to pay some fees to the ISP because we know that wide area networks interconnect different LANs to work together. Then LANs normally provide a very high bandwidth speeds because they use either wired Ethernet connectivity or wireless services, all right? Now, wide area networks, on the other hand, provide from low to high bandwidth speeds, but over very long distances since they connect LANs in different geographical stations, okay? And so looking at the diagram that we are having here, we can see that we have an enterprise campus here where we have different, the campus backbone here, campus network. Your building backbone is here. We have a remote worker or remote user here. We have a telecommuter here, a small office there. And then we have the branch office here. And then we have in the middle here, we have the wide area network infrastructure, which is being used to interconnect all those networks to work together. And a very good example of this could be a bank with different branches, or a university, or a company that has different branches, but they need all their networks to be connected to work together. Now, we have WANs having two broad categories. Some WAN connections are private, while others are public, okay? Normally, a private WAN is always a dedicated connection to a single customer, okay? And they provide security very, very consistent bandwidth, and they guarantee service level. There's a lot of reliability within their network. The public network, on the other hand, normally provide an ISP, or the telecommunication service provider, using internet, and bandwidth normally varies, and in most cases it's a shared connection, and elements like security are never guaranteed. Okay, security is never a guarantee. Now, WAN comes with different topologies, and so we have, of course, point-to-point topology. We have a hub-and-spoke topology. We have a dual-homed topology. We have a fully meshed topology, and we have a partially meshed topology. So we want to look at them one by one. So a point-to-point topology basically employs a circuit between two endpoints, that is, between two routers found in different locations. Okay. So the point-to-point connection, normally it's very transparent to the customer network. The customer is never aware of that. So two sites, like two routers found in different locations, and they are connected, you see a point-to-point connection. And this kind of dedicated connection is one of the most expensive in terms of seeking for internet connectivity, and it's more expensive relatively to other connections. Apart from point to point, of course, we have hub and spoke topology. In hub and spoke, so you can see that we have a hub router, and then we have the spokes. All right. So the way in which the hub and spoke works is that they employ one is something we learned in CCNA2 when we are doing inter-VLAN routing. We call them sub-interfaces. So this kind of topology uses sub-interfaces, and they use something we call virtual circuits. Okay. But the only disadvantage we have here is that this kind of topology is very prone to a single point of failure. So that if the hub fails, then that is the end of this network. If the hub fails, then all the other customer routers, those spokes there, will not be able to have any connectivity. So they totally rely on the hub, which will be on all the time. Then apart from hub and spoke, we have what is called the dual home topology. This is like you're having two hub and spoke together, but it provides a greater redundancy. Okay. So we are having, the first hub here and the second hub, and each of the spokes, spoke A, spoke B, spoke C, each of them is actually connected to the two hubs. And this provides a very great redundancy to eliminate what we call single point of failure. It brings about load balancing, very important. Things like distributed computing, ability to have backup, so on and so forth. So this is a very effective one. Only that the only disadvantage is that they require additional devices. That is the only one. And of course, in terms of configurations, it might appear more complex sometimes to be able to make it work. Then we have a fully meshed topology, just like what we call a wire mesh. Okay, every device within this topology has a connection to every other device. So it's like multiple virtual circuits connected within the site. And this is the most fault tolerant, okay, because of the greatest level of redundancy. Every device is connected to each other. So that is a fully meshed. Then we have partially meshed topology, whereby the devices are connected, but not all of them are connected to each other. And we can, of course, just see the topology here. Now, in terms of carrier connections, there exist two carrier connections. A carrier connection is either single carrier, which means you only have one ISP connecting into the internet, And when the ISP infrastructure has challenges, then you must experience those challenges. If you do not do single carrier connection, then you do a dual carrier connection, and this provides some level of redundancy, and basically makes you to be more available in terms of connection. So you must sign to a service level agreement with these two ISPs, so that when one ISP has challenges, you still have a backup ISP to do the job. So that's why it is very important. Now, the next thing I need to talk about is evolving networks. We have every network starts very small, but then growth is imminent. They get to grow after some time. Okay. Now you realize that a network must always meet, the daily operational needs that are needed within it. Okay. And they must keep on adapting and growing according to the changes you experience within that particular company or organization. And so network designers or even administrators like you guys normally meet these challenges carefully, and you need to make sure that all your protocols, all your devices, and your ISP is well informed, and planning in advance needs to be done. Okay. Now, I'm going to give an example of a company. This company I'm getting a company just in fiction. It's not a real company, but it's a fictitious company that we're using to learn how an organization normally or a company grows. So we are going to call this company a span engineering company, and this company is going to be manufacturing fuel from domestic waste. So this span engineering starts very small. They're just beginning, and they have very few employees, probably just 2 or 3 employees. And they just have a broadband access, which connects them to the internet. They just have one wireless router, and then the two computers can actually get connected through the Ethernet port on the wireless router. They have a wireless connection to their end devices like laptops, mobile phones, and all that. And then they have one small printer. So this is span engineering just starting. Okay. At this point, they can't manage to have an IT department because they don't have money to pay the IT staff. Okay. So they just use a single connection to the internet, which is being shared across all the devices. Now, within the next about 5 years, okay, the span engineering network has grown, and they now decide to rent a building, right? They rent a story building, and they take the several floors, okay? Actually up to about 3 floors of that particular new building. So each building, each floor, there's a router, and then each router is connected to 2 switches within that particular floor. And each floor has staff, all right? This staff could be, let me just zoom this for you guys. Yeah, so every department is, every floor is having a department. So there's a marketing and sales department on the upper floor. Then there's the finance and accounting department. Then there's the engineering and production here. So at this point, they even have an in-house IT staff which take care of their IT needs. All right. They might be now having a firewall already to protect their network. They have both routers and switches. They have wireless access points. They have more printers, laptops, tablets, desktop computers. So the company has really grown, and now this organization is growing, but they are just in one building, which they have rented almost the whole of it within the CBD. Okay. Now, within another probably 10 years or so, the company has expanded, all right? And so if they were in the country, they've expanded and they've added some branches within the country, all right? And so they have some people that work remotely. They have the central office, okay? Now they start employing things like the metropolitan area networks, okay, to interconnect different cities. And they want to also connect the central office and the branch offices, okay, countrywide, okay? So this is like about another 10 to 15 years. The company's got branches now. Within the next 20 years, Span Engineering has grown to thousands and thousands of employees that are distributed across, the country. And so they now have to use things like VPNs, like virtual private networks, either site-to-site or remote access. And, the network has become very complicated. They have now moved to different parts of the world. There's offices in Africa, there are offices in North America, South America, there are offices in Europe, there are offices in Asia, so on and so forth. So that is Span Engineering. And so one thing we are trying to say is that look at how they started. And now after about 20 years, they are now found in different parts of the world. And at this point, they need to contact the service provider to be able to interconnect all their branches in different, it doesn't matter where you are, okay? And so that's a very good example of how growth takes place and why we need a wide area network, okay? To interconnect all our, isolated local area networks to be able to work together. So let's look at how wide area networks get to operate. So wide area networks normally operate within the first two OSI layers. They operate within the physical layer and the data link layer. So within the physical layer, there are protocols that are implementing WAN here. One is called the SDH, and basically these ones are majorly used by fiber optic. So the synchronous digital hierarchy. Then there's the SONET, the synchronous optical networking. We'll talk more about them soon. Then we have the dense wavelength division multiplexing, DWDM. Okay. Now, all these are actually protocols that are found within fiber optic. Then at layer 2, we have several of them here. We have the broadband, DSL or cable. We have a wireless network for the WANs, Ethernet or the Metro Ethernet. We have MPLS or multi-protocol label switching. We have the point-to-point. We have HDLC, the high-level data link control. And then we have the asynchronous transfer mode. You realize some of them are very old. Like the ATM is a legacy protocol. Frame relay is also a legacy protocol. HDLC is also less used nowadays. The most commonly used ones are the Ethernet, the Metro Ethernet, MPLS, and point-to-point protocol. Okay, so WAN networks, majorly, WAN networks normally operate within layer 1 and layer 2. WAN networks normally operate within layer 1 and layer 2. Okay. Now, let us look at some of the infrastructure that are found within the wide area network. And we are going to learn about some kind of infrastructures like the DTE routers, the DCE, the CPE. So like for the DTE, which is data terminal equipment, and the DCE, data communications equipment, looking at the diagram on the right-hand side, you can see the router there, which communicates to the LAN, to the subscribers or the end users that are within this building. The router that connects to them directly is the DTE device. Then we have the DCE. The DCE majorly is used to communicate with the provider. All right. So the DCE communicates with the users in the LAN. DCE communicates with the wider network provider. And then, of course, we have the CPE, the customer premises equipment. Majorly, these are the equipment that are found within the control of the customer's compound, and that includes devices like DE and DCE. We have what's called the point of presence, the POP. This is where the subscriber normally connects to the service provider themselves. And I can actually zoom this so that you can get to see more of this diagram. So we have the DCE here, DTE is here. We have the customer premises equipment right here. We have the demarcation point or the cable junction point. This is the point of the building or the locality that separates the client or the customer from the service provider's equipment. Of course, we have the local loop. The local loop, we have it just a minute. Yeah, we have the local loop here, which is a connection mile, which connects the cable junction box on the customer premises to the central office, which belongs to the ISP. The central switch is normally found within the local central office. This is the office of the service provider, which is closer to the customer. Remember, there might be other customers around here. So the ISP will be able to have some devices within the locality that will be able to service or provide services to the clients around this area. So that will be the local central office, which is always connected to the toll network. This is the main or the core network of the ISP. Very, very important. The core network of the service provider. Now, what are some of the devices you normally find within the ISP? We have devices like the voice band modem, okay, for telephone lines. We have the DSL modem, the digital subscriber line modem. We have the DSU or CSU. We have the optical converter, wireless routers, WAN code. So let me just zoom in this so that you can be able to see them. So the ISP will normally have several devices, basically connecting different clients. So like you can see this optical converter, which converts fiber optic to Ethernet media. We have a wireless router, which of course, converts the wireless signals or connects the wireless signals to a wired signal or wired to wireless. We still have a serial connection here, which connect, with a CSU or DCE connectivity here, which converts from serial to Ethernet, all right? And of course, we'll have a cable modem here for the cable network. The cable network is normally the TV network. And we have, of course, the voice broadband for telephone. This is now for voice traffic. Okay. And of course, we have the DSL modem, the digital subscriber line for internet connect. So different type of devices. The layer 3 switches are here. The main routers are here that are able to provide connectivity within the service provider network. Now, the service provider network can either be circuit switched or it will be packet switched. All right. So for the circuit switched network, and a virtual connection must be established through to the service provider network before any communications can begin. Okay. If you want to know this, when you're making a call, for example, you are making a call, whether with your mobile phone or with a voice over IP phone, you pick the phone, you dial in the number or the extension number, and then the phone will start ringing. And then it is until the person on the other end will lift up or pick up the phone, then the connection will be established. So that's what we are saying. For a circuit switched connection, a connection has to be established. A dedicated a connection has to be established before any communication can start. Okay. And all communications are going to be using the same path that has been established. And the two types of the circuit switched communications include, we have the public switched telephone network, PSTN, and the ISDN, which is the Integrated Services Digital Network. So two types of a circuit switched communication is the PSTN and the ISDN, all right? And we will talk about the public switched telephone network and the Integrated Services Network. Then apart from circuit switched communication, we do have the packet switched communication. This is the one we have been talking about for some time now. Remember when we talked about packets in CCNA1? So data is always segmented into packets which are routed over a shared network, okay? And the packet communication is less expensive and normally more flexible than the switching, okay? And common types of packet switched WAN technologies include the Ethernet WAN, which we will be learning different names of the Ethernet WAN. We have the MPLS, the multi-protocol level switching. We have the legacy protocol called frame relay, which is a very old one. We no longer implement it. And then we have the ATM, the asynchronous transfer mode. We'll talk about all those ones. Now, having talked about the packet switch communications, in terms of the WAN operations, I want us to talk about these three protocols, which are majorly used for fiber optic service providers, okay? And so currently, most service providers implement fiber optic infrastructure because they need to transport their data for very long distances and within a very short time and at very high speeds, right? And that's why fiber optic is much superior than the copper medium, and because of some of those. And finally, you know that fiber optic is less affected by the different interferences that are available that we did talk about. Things like the electromagnetic interference, things like attenuation, things like crosstalk and all that, all right? Now, there are two major fiber optic standards available for service providers. Now, the one that is commonly used globally all over the world is the SDH. The SDH, which is the synchronous digital hierarchy. This is the standard that present and transport data over the fiber optic cable, but globally. Then in North America, there exists a standard called the SONET, the synchronous optical networking, okay, that also provides the same services as provided by the SDH. Now, these two protocols, the SDH and SONET, they define how to transfer multiple voice, video, and data communications over the fiber optic using either the laser light technology or the LED light technology over very long distances. Now, because there's more research going on, even within fiber optic, since this is one of the best things that ever happened to us, a technology called the dense wavelength division multiplexing, DWDM, it's new in town, and what it has done is that it has increased the data carrying capacity of both SDH and SONET, okay? And that's why it can simultaneously send multiple streams of data using very different wavelengths of light. And one of the research that has been found is that the dense wavelength division multiplexing can actually carry light traveling in different directions. And that is a very, very big thing. And so, and it can carry up to about, I think, 8 fibers, 8 of those small fiber wires. And so if one of them was carrying traffic at about 1 gigabit per second, 8 of them will carry traffic at a speed of 8 gigabyte per second. If it was in Mbps, one carrying 100 Mbps or 1,000 Mbps, then that will be at 8,000 Mbps. So fiber optic is the best thing that ever happened to us, and we want fiber optic to be here for longer. And with the technologies like dense wavelength division multiplexing, I think the internet will become much and much faster with time. Let's look at some traditional WAN connectivity options. Thereafter, we will look at the modern ones, and then we look at the internet connectivity options. Okay. All right. That's okay. So, talking about the traditional connectivity options, we know that we need to know where everything began. Okay. And so when we started using the internet, the local area networks, way back in 1980s, organization, they began to see the need to be able to interconnect their isolated local area networks, okay? And so they needed networks that could be able to connect or to loop through from the service provider, okay? And so this was accompanied by using things like the dedicated lines, okay, or some switch services from service provider. And so looking at the diagram that we have here, we have under the traditional connectivity options, we have the dedicated connection, and a very good example of dedicated is the list lines. And list lines could either be in form of T1 or E1, or it could be T3 or E3, okay? And this was the one of the most expensive ones, as we'll be talking about it in a minute. Then apart from the dedicated options where the customer got internet directly from the ISP, that's what made it very expensive. Then we also had the switched connectivity options. So we had the circuit switch, which we already talked about, and the packet switched, okay? And the circuit switched were only two, like we had already talked about it. The PSTN, which is the public switch telephone network, and the ISDN, which is the integrated services digital network. The packet switched connectivity options included very older technologies, which we no longer use again. Frame relay, the asynchronous transfer mode, and all that. So all these traditional options are all legacy. When you see the word legacy networking, then what that means is that it's an older protocol and it's no longer being implemented simply because we have newer ones. Okay. Now, talking about the dedicated list lines, the list lines were always available in different capacities, but the pricing was at another level, okay? So the two systems, they used to define the digital capacity of a copper media serial link. And talking about the T3 and E3, T1 and E1, the T carriers are basically used in North America, and the T1 supports up to about 1.544 Mbps. The T3 links used to support about 43.7 Mbps. The E carriers, E1 and E2, were majorly used in Europe, all right? The E1 could support a bandwidth of up to 2.048 Mbps, while the E3 links could support bandwidths of up to 34.368 Mbps. Now, you realize that these are very low speeds that, if you told someone that you are connecting to the ISP and they're giving you these Mbps's, they wouldn't believe you. And that's why, we need to look at what are some of the advantages and disadvantages of this used to be, connection to the ISP, the list lines. So there was a lot of simplicity with the list lines because the link required very minimal installation and maintenance. Then it was quality, the bandwidth was it was good to stable, high quality. Then it was always available. It had very little interferences. It was a permanent link, dedicated capacity. was required for voice over IP and even video over IP communications. Now, the major disadvantage of this particular list lines or dedicated list lines was list lines were very expensive. Okay, they are the most expensive of all the WAN access options. Okay. Now, the other, disadvantage was that it lacked some flexibility. All right, because when the traffic was often variable, or you needed to connect someone to the same network, then this person, they needed to contact the ISP directly. So the bandwidth of the line normally matches the need exactly that it's been fixed for. Now, for the circuit switch connections, we talked about the PSTN and the ISDN. The PSTN, which used it's one collection. Normally, it involved a loop which could transport the binary computer data through a voiced telephone network using a voice broadband. Okay. Now, it could only support less than or equal to 56 kilobits per second, and that is very low. While the ISDN, normally this is another circuit switch technology, which could actually carry digital signals, and the capacity was a bit lower, and it provided a bandwidth of between 45 kilobits per second to 2.048 megabits per second. And so these are very low speeds, and that's why we are moving away from these traditional connectivity options. Okay. Now, for the packet switched ones like the frame relay, these are very old technologies again, and we used to study them in CCNA in the version 6.0 and 5.0 of networking of CCNA, but they were actually removed. Cisco removed them from the curriculum because they were very considered legacy. Okay. Now, so frame relay was a simple layer 2 non-broadcast multi-access WAN technology, which used to use interconnected enterprise LANs. Okay, so it could use virtual connections, the private virtual connections, which will uniquely be identified by a data link connection identifier, what's called the DLCI. So they also provided very low speeds, but like I said, we no longer use these ones. The same thing was the ATM, the asynchronous transfer mode, which used to use cells. It was a cell-based architecture. Yes, they could transfer both voice, video, and data through both private and public networks, but they only had a fixed length of 53 bytes, and that is not a very good one. So most of these technologies have actually been replaced by either the Ethernet technologies or the internet-based solutions. And at this juncture, I want us to talk about some modern WAN connectivity options after we removed all the other legacy connections. And so the modern ones currently, they have more connectivity options than the traditional ones. Traditional ones were a bit fixed, and you realize that normally the current enterprise networks, big organizations, universities, campuses, companies, they require faster internet and more flexible WAN connectivity options. We realize that the traditional options, they have currently rapidly declined in use because either they are no longer available, they're too expensive, or they have some limitations in terms of bandwidth. And so the table here summarizes some of the current or the modern connectivity options. And, we can't help but to identify first the cellular option, which is basically is used by our mobile phones and tablets, and, the cellular network. We call it cellular because the network or the network within the area of this cell tower is called a cell. And that's why we call your phone a cell phone. All right. Of course, we have the wireless options, which we will, of course, still talk about. We have satellite connectivity options, Satellite is a type of option, that normally requires a clear line of sight from the satellite dish, which installed within your building, and the satellite ISPs. They have to be able to point your satellite dish with a clear line of sight to the satellite orbit found within space. All right. Otherwise, we still have the fiber, the optical fiber connectivity options. We have not just the DSL, but we now have the XDSL as an option here. And for our TV content, we have the coaxial cable, which still connects us to the network. So these are some of the modern WAN connectivity options. And looking at this table, this diagram here actually explains all. We now have a dedicated connection, but we don't have a list line anymore. We have a broadband, which gives us something we call the dark fiber. Okay. We have a switched connection, and the only switched connection we have here is the packet switched. We no longer have the circuit switched. It was obsolete. So under packet switched is where we have the Ethernet WANs and the MPLS, which is still being used by some ISPs, the multi-protocol label switching. But we have just added, we have the broadband, the internet-based connectivity options, where we have the broadband VPNs, which includes things like the XDSL, the cable network, the fiber optic, and we have, those are wired. Then under wireless, we have the municipal Wi-Fi. We have the cellular technology, the satellite internet connectivity, and we even have the WiMAX, the worldwide interoperability for microwave access. Now, the dedicated broadband fiber normally is always installed independently by an organization, and this is used to connect remote locations. And a very good example is the dark fiber, which you can either lease it or purchase it from the supplier. The packet switch network, they have replaced most of the traditional WAN networks, and the MPLS, which basically enables sites to connect to the provider regardless of their technology. For the internet-based solutions, now very ubiquitous and very common, using the global internet infrastructure for the WAN connectivity option. So let's start by talking about the Ethernet WANs. Now, the Ethernet WANs are normally offered by service providers using fiber optic cabling, okay? And the Ethernet WAN goes by so many names, including you can call it the Metropolitan Ethernet, you can call it the Ethernet over MPLS, you can call it the Virtual Private LAN Service, VPLS, and they come with so many advantages. They have reduced expenses and administration. They are very easy to integrate with other connectivity options. They, of course, enhance business productivity, and I think it's made life much easier than ever before. Okay, and the Ethernet has gained a lot of popularity, and it's being used to replace most of the traditional options we talked about, like the ATM, frame relay, point-to-point, so on and so forth. Now, the MPLS, the multi-protocol level switching, is a high-performance ISP routing technology, which can be used to interconnect clients without regard to whatever access method they have, okay? And so they can carry and encapsulate a packet, whether it's IPv4 or IPv6, okay? They have different client access methods. You can connect through Ethernet, through cable, frame relay, or through the DSL. And an MPLS router can either be a customer edge router or the service provider edge router, or even an internal provider router. The routers are always label switched, routers, and that means that they attach labels to packets that are then used by other MPLS routers to forward the traffic. All right. So many services that MPLS can provide, including VPNs, traffic engineering, redundancy, quality of service, so on and so forth. So that is MPLS for us. Now, for the internet-based connectivity options, where we have either it's wired or it's wireless. The wired options use a permanent cabling like copper or fiber optic to provide a very consistent bandwidth and, of course, reducing any errors and latency within the network. Fiber optic cable connections, DSL, can be a very good example. The wireless options, they always are less expensive because you implement them using just radio waves instead of a wired medium, okay? And so we have things like the third generation network, fourth generation, what you call 4G, and now 5G, and including the satellite, satellite internet connectivity options, okay? Now, talking about the wireless options, you know that wireless has a lot of interferences, and if the radio towers you're not closer to them, or there are interferences from other sources like weather, then you run into trouble sometimes with wireless networks. But let's start by talking about the DSL connections, okay? And so the DSL, which is a setup between a DSL modem and the DSL access multiplexer, what is called the DSL AM, they normally convert the Ethernet signals from a teleworker device to the digital signals here, which are transmitted within the DSL multiplexer. Now, DSL normally is not a shared medium, so each user has a separate direct connection to the multiplexer, okay? And adding any users will not impede the performance of this network by any chance. DSL can work over what's called the point-to-point protocol, PPP, right? PPP. So DSL, ISPs normally, they have used PPP as a layer 2 protocol for broadband DSL connections. So they can actually use it for authenticating providers, providers that need to pay like monthly. So they'll assign a public IP address to the subscriber, and they provide some link quality management features so that if a subscriber has not paid his subscription fees, then because PPP uses other authentication protocols to be able to do that, they'll actually be denied access to the network. So PPPoE, which is the point-to-point protocol over Ethernet, can normally be deployed in two ways. And either we'll have a host with a PPoE client or PPoE software, which communicates with the DSL modem using the PPoE, or we can have the router itself having a PPoE client, okay? And it will be able to obtain its configuration from the provider. So we do have currently most of small internet service providers, they normally they use PPoE in order to control who has paid and who has not actually paid them. Now, it's important to note that for all of us who consume internet, who consume TV content, the cable technology has been here for a very long time, and it has a very high speed, always on connection, which uses the coaxial cable from the cable company to provide some of these IP services to the users. So it has what is called the DOCSIS, the Data Over Cable Service Interface Specification, which has international standard for adding high bandwidth data to an existing cable network. So it has what is called the CMTS, the Cable Modem Termination System, which is enabled by fiber optic to travel over long distances to the provider head end. So normally it contains databases all over the world, which provide the internet access and services, while the CMTS is responsible for communicating with the cable modems. Now, this cable technology is normally a shared medium, and as major users join the service, the bandwidth will always drop below the rate, and you start experiencing some of those low connectivity options. Fiber optic, as we have been talking about it, and we did talk about the three technologies under fiber optic. Currently, most countries, cities, ISPs, they install fiber optic cable to even user locations, okay? And this is provided a term that's commonly referred to as FTTX, fiber to something, okay? So you can have fiber to home, which just a fiber connectivity to a residential, fiber to a building, which is fiber connectivity to a certain building as a final connection to individual spaces, or you can have fiber to node or fiber to the neighborhood, which is a cabling connection which reaches an optical router or converter, which converts the signals from either fiber optic or the light pulses to the electrical signals within copper in either the twisted pair or the coaxial cable. Okay. Now we have, of course, the wireless internet-based broadbands, and here we have what's called the municipal Wi-Fi. The municipal Wi-Fi is actually a wireless network normally found within a city or a town. All right. So a wireless network providing connectivity at high speeds within a certain city. Then, of course, we know the cellular network, which it's become very popular, using electromagnetic waves to communicate through nearby mobile telephone towers. And we have the 3G, 4G, 5G, and the latest one, I think, is the LTE, the long-term evolution, which is still under the cellular technologies. For very remote places and, things like the ship in the ocean, the aeroplanes in the sky, in the desert places where there's no any other connectivity, satellite internet has been a very good one, even in rural areas. And, it's normally providing internet services in synchronous orbits, okay? Sometimes it might be impacted by trees or even heavy rains. Then we have the WiMAX, the worldwide interoperability for microwave access. This is an IEEE 822.16, high speed, more than Wi-Fi, but it covers very large areas, very long radius of connectivity. Of course, we have VPN technology, and a VPN basically normally is used to address remote concerns and security concerns. So a VPN is used for remote secure access, okay? So VPNs basically are just channels which will route traffic through the public internet, okay, to a remote site or a remote employee. And there are several benefits of using VPNs. They are very cost saving because they eliminate most of the expenses that will have costed you if you're not using a VPN. Then they're secure because of the encryption and authentication involved within them. They are very scalable because the more people you add on your network when you're using a VPN, you're not charged, for adding more people on the network, and that's how it's a bit scalable. Then it's compatible with other broadband technologies like DSL cables, on and so forth. So normally we have two types of VPNs. We have a site-to-site VPN and a remote access VPN. So a site-to-site VPN is a kind of a VPN whereby you are trying to map two particular sites. Let's say a university has two campuses, like Kenyatta University has Mombasa campus and it has the city campus in the CBD. It might want to map the two campuses using a VPN. So the VPN is actually installed in the router in each of the campuses. So the users who are using that network are never aware that they're actually using a VPN because they don't need to log into anything. They just need to be connected to that network. And once they are connected, every traffic they emit will be protected by the VPN. That is quite different with a remote access VPN, because in a remote access VPN, the user is always aware that they're using a VPN because before they start using the VPN, they must log in with their username and password, their credentials. That is the difference between the two of them. Now, in terms of ISP connectivity options, we have the following. You can either be a single homed connectivity options. You are getting internet from one ISP. Dual homed, you are getting double connections from the same ISP, all right? The same ISP provides you with two links so that when one link goes down, the other link is still available, but from the same ISP. Then we have multi-homed. For multi-homed, you now get two links from different ISPs, all right? One from one ISP, another from another ISP. And then the most expensive one, and it's also the most redundant one, is called dual multi-homed, whereby you have two ISPs, they each give you two links so that you are always on all the time. Even if one ISP was to go down, all of it, at least you still have another ISP giving you two links. And even if, each link will be off from each ISP, you still have a separate link working for you. Now, in terms of these broadband solutions, each broadband will always have its own merits and demerits, okay? And so there are several of these solutions available, but you need to check some of the factors to consider before you choose which connectivity option that you want to implement in your network. So when you're choosing the cable network, just know that the bandwidth is always shared, and therefore sometimes it can have upstream data rates to be a bit lower than the downstream. That means uploading could be a bit slower or low bandwidth than downloading. Then when you want to choose DSL as your connectivity options, the distance sensitivity, which is important in relation to the central office of the internet service provider. And within DSL, uploading data rate, it's always proportionally lower. It's always proportionally lower than downloading. When you choose fiber optic, this requires fiber installations directly to the home. And so you have to dig the fiber channels, those channels to be able to bury the fiber optic below the ground. When you choose to use the cellular, connectivity option, normally coverage is always an issue because you must always, for this option, you must always be closer to the cell towers. Otherwise, you'll always experience some problems with connectivity options. And sometimes bandwidth could be a little bit limited for the cellular options. Now, for the municipal Wi-Fi, most cities do not have the mesh Wi-Fi network deployed. So because this requires a mesh technology, mesh Wi-Fi network to be deployed. And if that is available in the range, then it's a very viable option for you. Now, satellite is a bit expensive, but it also provides very low bandwidth to its subscribers. And it's always the last option. When you don't have any other connectivity option, then you will need to go for the bandwidth. I think for this, I want us to actually stop there, but I want us to talk about VPNs very, very briefly. We have talked about two types of VPNs. We have the digital subscriber line. We have the site-to-site VPN, and the other one is called